Hey guys, welcome back to the show. Today's episode is one of my favorite topics, and that is how to help the body to heal from within. Those of you who listen to the show know that is literally my favorite topic to talk about. So my guest today is an expert in this area, and I've had him on before. He's a repeat guest. So it's always fun to have people back on the show a couple of years after the first episode and talk about what they've been up to, all the new things in their world, and how things have grown. So in the meantime, of course, I want to thank you for being here. I'm so grateful for you guys being followers of the show, for your comments, your questions, and the reviews. Please continue to send those reviews on whatever platform you're listening to the podcast on. And of course, sharing the podcast with your friends, family, and network, because that is how we reach more people. So, and last but not least, if you haven't already done so, make sure to sign up for my newsletter at natnidham.com. There's a red bar at the top of the page that says sign up for Nat's newsletter. All right, let's get into the episode. So in this episode, I interview Christian Drapeau. It's the second interview with Christian. Our first one was 2 years ago when he was just coming into the market, and he is the author of an incredible book called Cracking the Stem Cell Code. This man knows this man knows stem cells like nobody's business. And so we talk about the power of really, this, like I said it before, this is my favorite topic. This is about harnessing the body's own repair systems by tapping into stem cells. And so we have a big discussion on stem cells. We talk about what happens to our stem cells as we age, different ways of supporting them, lifestyles, why they're being challenged these days, and why people are really getting into trouble here. And we then really kind of dive into how we can help to increase the stem cells circulating in our body and tap into them. And, look, regenerative medicine is the medicine of the future. We know this. And so right now, people with no end of money can run around to different countries and have stem cells injected into themselves. But listen, what if there was a relatively affordable way of mobilizing your own stem cells on call when you need them, right? What if you could do that? And we talk about that. We talk about free ways you can do that. And we talk about a novel way to do that. And that is through a formulation that that Christian has developed over the last couple of decades, really, and refined. So we also talk about stacking stem cell therapies. It's a great episode. I mean, honestly, if nothing else, it's a deep dive into the world of stem cells, and particularly your own stem cells. And we know that the best source of stem cells is going to be from yourself. So check it out. It's a great conversation. If you want to learn more about Christian, you can follow him on Instagram. It's at Stem Cell Christian. And also, if you decide after you listen to this episode that you want to get your hands on Stem Regen yourself, which is the supplement that he's formulated, you can go to stemregen.com and use code NAT15 to get 15% off your purchase. And that's about it. So once again, the book is Cracking the Stem Cell Code. And I think you're going to really love this conversation. And now let's dive into the episode. Hey folks, just a quick reminder that all of the information presented in this podcast is for information purposes only. No medical advice, no diagnosing, no treatments suggested here. Before you try anything that you hear about or learn about here, make sure that you check with your medical provider. Welcome back to the show, Christian Drapeau. I am so excited about this conversation.
Me too. It's been a while.
Yeah, we see each other a lot, but we kept saying, "Oh, we must record another podcast." Like, we'll put the link to the first episode that we recorded together ages ago now. Like it feels like eons ago, and ever since then we've kept in touch. We've seen each other at conferences. I've been expounding the virtues of Stem Regen to everybody I meet. And I think it's now been a year that we've been saying we need to record another episode. So I'm really excited that we finally managed to carve out the time before you take off on your first holiday in 20 years, you were saying,
That's
which
right.
is
Yeah.
well earned. Well earned. So, Christian, to get started, like you've really done an incredible job in this space of and it's the stem cell space, but it's different than most people. Like most people talking about stem cells really usually are talking about introducing stem cells either from another source into the body or harvesting stem cells from fat or bone marrow. So they tend to be very invasive procedures.
Mhm.
Your approach to stem cells is quite different. And it's really about marshaling your body's own resources. So I guess maybe, even though we may have talked about this in the first episode, can you talk a little bit about how you came into this space and decided that, and discovered what you discovered?
Mhm.
Because, you
So
do have fairly unique.
my background is brain research, neurophysiology, and I was hired in 1995 by a company in Southern Oregon that was selling Klamath Lake blue-green algae. So the product was very popular in the 1990s, and the benefits that people were reporting was benefits on inflammation, on the immune system, and many people were experiencing an increase in mental clarity, just an overall feeling of well-being. So my first task was to document the mechanism of action behind these benefits so that they could make claims that would be in line with, at the time, the newly voted or passed DSHEA, the Dietary Supplement Health and Education Act. So very quickly, we identified the mechanism of action for these benefits. But as I'm doing all this work, I came across people reporting recovery from multiple sclerosis, liver failure, kidney failure, emphysema, diabetes, heart disease, Parkinson, Alzheimer's, and so many different types of problems, but more importantly, touching different aspects of human health. That the question was, what is this plant doing, touching so many aspects of human health? And of course, at first, it's I wouldn't say a denial, but one case is one case. 10 cases, well, it's 10 cases. But when it's 50 cases, it starts to be compelling. Then some of those, I had access to the medical records of these people, and definitely there's something here that was not normal. So, and that's what created the motivation to dig into what this product was doing. And we had no real explanation until 2001. I came across the first article, to my knowledge, documenting stem cells going from the bone marrow to the brain. The title was Turning Blood into Brain, and the title of the article. And so we go back in 2001. Stem cells are only precursors to blood cells. They make red blood cells, platelets, and lymphocytes. They're not known to make anything else. And of all things, we know that the brain does not regenerate. So to find a stem cell to go to the brain and becoming a brain cell, I thought it was pretty groundbreaking to me.
Yeah.
So it's pre-internet, or at least pre the time when the scientific literature was on the internet. So I went to the local library, start to dig into the scientific literature to see what else I could find. And I found another article documenting stem cells capable of migrating into the liver and becoming liver cells, and the same thing in the heart. So put yourself in my shoes. We're in 2001. Stem cells are not known to do anything but blood cells, but here are 3 studies documenting that stem cells can become liver, heart, and brain. Then why not pancreas, lung, skin, and the rest? Makes no sense. So that means it was just a matter of time that scientists will document that they can become other things as well. So let's assume that they can become everything. That means they have to be the repair system of the body. How can a stem cell, it will be like looking at an immune cell, seeing the immune cells going in the body at the site of an infection and killing a bacteria, and looking at this and thinking, oh, what a bizarre thing that randomly the immune cells killed the bacteria. It's not random. It's very well orchestrated. They are your protective system, your immune system. So if stem cells can become brain, heart, and all of these, they have to be the repair system. So we published an article in a journal, Medical Hypotheses, suggesting, in 2001, suggesting that stem cells are the repair system of the body. And in the back of my mind, the weird, crazy idea at the time was, what if this plant triggers the release of stem cells from the bone marrow? It's just not something that anybody has looked at before. So we acquired a flow cytometer, starting to count stem cells in our own blood at first. And then very quickly, we discovered That's what the plant was doing. So I thought, honestly, I thought it was one of the biggest discoveries of our time. So I dropped everything else and I dove into stem cell research. So since 2001, that's pretty much all that I have done. So that's what led me to the whole field of stem cell research.
Wow. Okay. Wow. 20 years you've been at this.
20, yep.
That's quite something. Well, it's interesting, right? I mean, and we were talking about this earlier, and maybe you want to talk about this as well. It's how long it takes for new concepts to grab hold since the beginning of time, right?
Yep.
Like we as a society have our beliefs, and you were talking about the discovery of, and I remember actually recently reading the story about the doctor that first proposed that other doctors who are delivering babies should wash their hands before. Was it through you or something?
No, but I know the story. It's amazing. Yeah.
Right.
Yeah.
Like he first proposed, he said, hey, all these moms are dying of these weird things. And this is going way back. Like, I don't even know when this was. And maybe we should all wash our hands. And he started washing his hands, and sure enough, fewer of his patients were dying, but he was ridiculed by the medical profession. And it wasn't until much later that we finally came to it. And so, this idea that you would kind of stumble upon something like this. And what's weird is the papers are there. Anybody could have seen them.
Correct.
But for you, somehow it rang a bell and you kind of went, wait a minute here. There's something we're missing. And I think this is it. And now 23 years later, we're sitting here having this conversation.
That's probably, if I were to point at something, that's probably the one gift that I have. I'm an eternal skeptic. Anything that I see, it's like, let's see. So I never deny anything. Let's see what's in it. So and what I'm saying here is that every new discovery always happens within a context that has beliefs in it, dogmas. And if that discovery goes against those beliefs, it's amazing to see how it takes time for these things to penetrate until they become obvious for everybody. So what you talked about before, hand washing, it's a great example. Bacteria were discovered in the late 1600s, like 1670s, something like this, by somebody who had developed a microscope to count thread densities in textile for quality control. And then he was curious. And one day he looked at a drop of water on a peppercorn and he saw little things swimming. That was the discovery of bacteria. So now bacteria are in drops of water that are on peppercorn. So, and then suddenly they see it on the drop of water that was on another surface and then another surface. So now it's 3 different surfaces. And so you see the slow discovery, the slow process until we know today they are everywhere. There's not like a square inch of this planet that does not have bacteria. They are absolutely everywhere. Then we discovered they're the cause of tuberculosis, pneumonia, cholera, all these different problems. And decades later, somebody started to think about maybe washing your hands, might just be overall good for health. And my point in describing this whole process is that from the moment of the discovery to the moment where it's adopted, the new discovery, although it was not less true before it was accepted, it does not sink through the general population because it goes against like deeply held beliefs. And I think that we're facing exactly the same thing here with stem cells. You have a repair system just like you have an immune system. It's literally the same thing. It's a specific tissue, your bone marrow, releasing a specific cell, the stem cell, that is going to go and follow very specific molecules that will coordinate their movement in the body, leading them to wherever you have an injury, where stem cells are called to migrate in that tissue and repair. You have a repair system just like you have an immune system. But we live in a world, we were talking about this before, we live in a world where cure is just not part of our belief system. What disease do we have that we cure? What age-related degenerative disease? I'm not talking about pneumonia, because now we go back to the bacteria. That one now is accepted. But any so-called degenerative diseases, you have heart disease. We reduce your blood pressure. We give you beta blocker to protect your heart. We do a lot of things to wrap up the problem, to increase your quality of life. We never do anything to repair the heart. You have diabetes. You get insulin every day of your life for the rest of your life. We never repair the pancreas. And you look at any problem, cure is just not part of our language. And yet, we all know that we heal. We've all had broken bones and cuts and bruises when we were kids. They're gone today. We have all experienced the amazing ability of the body to repair. And in our 50s, we sort of forgot that the body can repair. And that's what we're discovering with stem cells. That is what stem cells do in the body. Stem cells are the repair system, and the reason why we don't repair in our 50s, like when we were 5 or 10 or 15, is that the number of stem cells, the red marrow that makes stem cells, converts into yellow marrow that does not make stem cells. By around age 30, we have lost 90% of our red marrow, and that corresponds to a 90% decline in the number of stem cells in circulation available to participate to this process of tissue repair. So we have a repair deficit as we cross, let's say, our 40s, and that is why we develop all kinds of problems. So that's what we need to understand. Stem cells are literally the repair system of the body. It declines as we age, and that decline becomes the fundamental cause why we don't repair as well later, and even why we develop so-called age-related problems.
Right. And but the stem cells are there, but they're not necessary. I think what's interesting is as we age, like they're more available in youth and less available, like, because even though a lot of the red bone marrow converts to yellow bone marrow, where we know, which has fewer or no stem cells in it, we still have a reservoir of stem cells left behind. Like, we're never without them. It's a question of what can we do to encourage the body to release them. Like, people will still heal in their 50s
Yes.
and 60s to a degree, depending on their health, depending on lots of different things. But obviously we don't heal as fast as we did when we were younger. But so maybe we can talk a little bit about, how is it that a young person can access these stem cells much more readily than as we get older. And it's not like they're not around as we get older. There's just maybe not as many, or they're not as efficient, because a lot of what people talk about in this stem cell space is you have different camps, right? You have the camp that says you need to go find the youngest stem cells possible because those are the only ones that are going to fix you. And then you have the other camp that says, no, wait, you have stem cells in your bone marrow, you have stem cells in your fat tissue. We can harvest those stem cells, reintroduce them into the body. And in some cases, we'll harvest them, we'll multiply them, and then we'll reintroduce them into the body. And these are all, that it's an area that's growing, but it's wildly expensive and it's incredibly invasive. And, from what you're saying, it's like, well, wait a minute, you've got it on board.
Yeah.
Surely there's a way to kind of re-engage it.
Okay, many layers to the question.
Yeah,
so let's start with what you were expressing at the beginning. The best analogy that I have found, and it's not a great analogy, but hopefully will help understand. Think of your bone marrow as a series of wells. And you're born with 100 wells, and as you age, you lose wells. But any wells that remains produces water. And if you have a well that has, let's say, 10 feet of water, if you go and you pull out 20 gallons, it will still be at 10 feet. Pull out 100 gallons, it will still be at 10 feet. Pull out 300 gallons, a well will tend to be fed and maintain its level. In the bone marrow, you'd call that homeostasis. The bone marrow has an amazing power to always maintain a set population of stem cells. It's just that your red marrow shrinks. You have fewer and fewer wells. So you have access to less and less water or stem cells as you age, though the red marrow that you have still remains very productive. You just have less marrow to make stem cells. So as a consequence, the main difference between at 50 compared to 15 is that you release less stem cells. You have less marrow capable of releasing stem cells. So you end up with fewer stem cells in circulation and therefore fewer stem cells available to participate in the process of tissue repair. Now, stem cells decline in their regenerative power over age. And that has been seen in studies like, for example, the typical study, you take a 10 months old mouse, which is a relatively old mouse, and you trigger an injury, and then you inject in that mouse 14-month-old stem cells coming from a 14-month-old mouse, which is fairly geriatric, and then stem cells coming from a 1-week-old mouse. And as you do this test, you see that the young stem cells are much more effective at boosting repair than the old stem cells. So it's undeniable. The effectiveness of stem cells decline as we age. I think where that has led to a completely wrong message that is in many places out there, on YouTube, I see it many places, that therefore past age 40, your stem cells are irrelevant, like they don't work.
Don't bother.
This is completely false. And what I mean is that, for example, the product that I have developed, Stem Regen, so it's a blend of plants that put more stem cells in circulation. We have an ongoing study, we can come back to that later if you want, but we have an ongoing study on stable congestive heart failure. The study is ongoing. We only have 10 people now that have gone through the whole process. But of those 10 out of 10 have normal heart function 6 months later. They are between 68 and 76 years of age. And they have just released their own stem cells. That's the only thing that has happened for them. So would it be better if they released stem cells that were much younger? Yes. But my point is that it's not their own stem cells are not irrelevant at all. They still can do very, very good repair. So when we take that into consideration, that means you have less and less stem cells, less and less red marrow as we age. So now if you want to get an injection of stem cells, then you have the two camps that you talked about, those that will say you're better with umbilical cord stem cells, young stem cells, and they all have their pros and their cons. So young stem cells, when you inject stem cells in the bloodstream, they will go back to the bone marrow. That's how, like, you trigger cancer treatment. You irradiate a person. When you rebuild the bone marrow for that person, the bone marrow transplant is not an injection of stem cells in the bone marrow. You just put them in the blood, they go back and they repopulate the bone marrow. It's a normal function of the bone marrow to release stem cells, but also recapture them. So that means that person who has now got an injection of young umbilical cord stem cells will have a new population of younger stem cells in the bone marrow. So somewhere there's a value of putting younger stem cells, but they are stem cells from somebody else. And that can bring two concerns. I cannot call them problems today because nothing has really emerged from this kind of intervention. And it's one, the fact that you never have 100% purity. So if you don't have 100% purity, you have particles from another person. So could that lead to low grade level of autoimmune problems down the road? Big question mark that has not been answered. So far, I would say the answer seems to be like, there doesn't seem to be a problem, but we just need to give it a little bit more time. So that's number one. Number two, if you get stem cells from somebody who have a different genetic background, material than what you have, normally this will be positive because you increase your genetic diversity, if you want, in your body. But what if you have a gene that is one that is more like prone to develop cancer? Then suddenly you have that in your body. So these are like the two cons. Would I consider them like big obstacles? No, I would not. So I'm not saying it's a bad thing to do. But when you talk about fat-derived stem cells, these stem cells are dormant. Your fat tissue are not known to like release stem cells. They're not really active, so they stay there. So when you extract stem cells from a 60-year-old person, those stem cells are not old. So are they like umbilical cord? Probably not like umbilical cord, but they're young stem cells. So that is the camp of those using fat-derived stem cells, is that you can take these stem cells and they are essentially young stem cells. They're not as pluripotent as what you find in the bone marrow. And that is why you can get some of these very expensive techniques, which consist in extracting stem cells from the bone marrow, extracting them from the blood. You spin the blood and you have the V cells, extracting stem cells from your fat tissue, adding some umbilical cord stem cells to that mix, blending all of that and using that as an injection. So all of this is I mean, it's great. It's brilliant. It's a good idea. What is forgotten in all of that is that We release them every day. We can easily boost them. Any one treatment would always be a one event. You get one input of stem cells, and that's it. Whereas if you can take products that are known today, plant extract that trigger the release of your own stem cells, you can do this every day for the rest of your life, boosting your innate ability to repair. I'm not saying it's one or the other, but there's definitely one that is much more affordable and can be used by anybody anywhere in the world. That's the field that I have developed and I'm focused on.
Yeah, no, and it's a magical field. Like, let's be clear. We'll talk about some of the case studies and research that you've done, which, you know, clearly you're onto something big. I keep, every time I talk to you and we talk about a case study, I shake my head and I'm like, why isn't the whole world just banging down your door yet? But they will in time. Right now, it's just those of us who are in the know. So, you know, that kind of works. And I think that you just mentioned also that there are definitely strategies that help the body to mobilize and release stem cells. And I would love to talk about that, because there's things that people can do even before, you know, I think the big stem cell treatments and the stem cell smoothie that you just talked about, which has your autologous stem cells and exogenous stem, like all the stem cells from all the different places, you know, in cases of huge need, like massive deficits or whatever the case may be, that may be called for. Like, it may be that you've got to bring in the troops from wherever you can find them to kind of help a situation. But I think for your more day-to-day issues, and even some of the degenerative issues you've talked about, like heart failure and diabetes and you know, kind of more like age-related chronic stuff. But again, as I'm saying that, you have cases where it's anything but that, right? And we're going to talk about those cases. But there's still things that we can do that increase the stem cell. And it's not, and I don't know if they're increasing stem cell production or if they're increasing the release or the mobilization of stem cells. So maybe you can kind of help to distinguish between those two things. So I'll stop there, because maybe you can distinguish between those two, and I'll start rattling off some of the things I'm thinking of.
Okay. So the first thing to understand in the context of what you just expressed is that it's just like your immune system. We know today that good sleep helps your immune system. Stress will shut down your immune system. Like, your immune system is core to your overall health. And when we discover stem cells, then everything looks like a discovery. Like, it's almost like we're surprised that something could have an effect on stem cells. We wonder, could sleep have an effect on stem cells? And I want to just take a little bit of distance from the whole topic. It is the body's innate repair system. Everything in your body that happens, that is broken, that needs to heal or repair, stem cells are involved. So anything that you can think of right now that you know helps repair, somewhere it has an effect on stem cells. And I'm saying this because we're early in this process. There is very little research that has been done, but we know that smoking cigarette, like you go for a surgery, they will ask you to stop smoking cigarette if you can around the time of the surgery so that you can repair, because it really reduces your ability to repair. Cigarette smoke will reduce the ability of stem cells to migrate in the tissue and proliferate. Alcohol in excess will do the same thing. We know how stress is associated with many kinds of almost like every single degenerative disease as stress as one of its component. Well, stress, the hormones of stress have been shown to shut down the ability of stem cells to migrate in a tissue and proliferate. So the point here is that we can talk about what we know, but I would say let's just not stop to just what we know. I think we need to conclude from that pretty much everything that we know is good for health somewhere has an effect on stem cells, and what we know is not good as a negative effect on stem cells. So of what we know, if we want to put more stem cells in circulation or help them do their job in the body, fasting for more than 3 days will increase the number of stem cells. So think about Mediterranean diet or calorie restriction. Think of like the Unzakut, you know, who live in the north of Pakistan, who live in an area that is so harsh, and they live like centenarians, many of them, but they have so little food that at the end of each, like in May, they run out of food. So they fast for about a month in that environment, which is a really, really rough environment. And they live like very thin, but centenarian. So you couple fasting with calorie restriction, that supports stem cells. Intense physical activity. We know that physical activity is really good for health. Intense physical activity will release stem cells. We also know that not intense physical activity, but just normal daily, some cardio activity is associated also with health. So what has been kind of documented recently is that if you do small, moderate cardiovascular, 20 minutes of how do you call this machine? Like your walking machine.
A treadmill.
Yeah. Treadmill. There you go. So do 20 minutes on your treadmill and moderate intensity. It's not going to put more stem cells in circulation. But if you have an injury, the day that you have that injury, you release more stem cells. So it's almost like your repair system is more primed and more ready to release. Is it because by pushing every day blood through all your microvasculature, the whole system is better equipped to deliver stem cells whenever it's needed? Because that's another part. If you don't have good fine capillary circulation, that's the only place that stem cells can do their job. They need to reach the fine capillaries. Oftentimes, a chronic injury is in a tissue that has chronic inflammation in which the circulation is very compromised. So that organ now is deprived of repair. So these are all systemic inflammation is another one. So having a diet, have a diet with a lot of colored food like berries and all these antioxidants. We've known that for ages that it's good for health. Well, it suppresses systemic inflammation. It makes stem cells more capable of identifying the organs and tissues that are in need of repair. So these are all things of normal daily life that we know can help the role of stem cells in the body.
Yeah, no, that's really interesting. I also think things like, getting into the less obvious lifestyle stuff, but things like pulsed electromagnetic frequency, by exposing the body to that low level kind of current optimizes cells in general. And it's what you're talking about, right? We improve microcirculation, we improve health of the cell, we increase the number of stem cells that are kind of mobilized and in circulation. And then the other one, which actually makes a lot of sense also, is red light and near infrared light therapy, because that also increases nitric oxide, which is going to help with your vascular dilation, the microvasculature.
Yep.
And
I think all of these techniques, the bottom line is that anything that improves repair or recovery is always happening because of stem cells. Yeah. It's stem cells that repair tissues, but we can support stem cells in many different ways. So these techniques like pulse electromagnetic frequencies has been shown to actually improve blood circulation. But I think that I saw somebody showed me studies not long ago. I need to go and dig them out and read them, but that it actually documented stimulate the migration of stem cells out of the blood into the tissue, the nearby tissue. So there's a direct effect on stem cells. Now you talk about red lights. Nitric oxide, improved capillary circulation, but also mitochondrial activity. So now when one stem cell migrates in a tissue, that stem cell one stem cell in a tissue is completely irrelevant. It would be like a bee, in your beehive, if you want to collect honey, completely irrelevant. It's many bees that will do the job. So that stem cell must multiply into thousands of progenitor cells that will then become cells of that tissue. So when you have 1 million stem cells migrating in a tissue, it's billions of tissue cells that will really make a difference in that tissue. So think of the need in mitochondrial duplication and mitochondrial activity. So you simply bring anything like NMN. I have a friend who's using Stemregen and NMN, and he says, man, the synergy of these two products together is for him unbelievable. And I think that the reason is just for that. You boost the vitality, if you want, of all these new cells in the tissue. I believe that when this gets fully investigated for what it is, 20 years down the road, in a textbook of physiology, they will say one of the biggest metabolic demand of the body is new cells emerging from stem cells in your tissue, taking part in this whole process of tissue renewal. It's going to be like known as one of the main process in the body that requires vitamins, minerals, building blocks, collagen, amino acids, all of that. Yeah. And so it's very significant. And yet until now, completely absent from our medical language.
Yeah. Well, the concept of doing something to support the release of more stem cells when you need them. And also, and I love what you just said, because definitely, when I've been working with clients or people in my communities, well, there was one woman, I think, I'm not sure if she ever ended up making the video for you, but she had broken her clavicle, cracked 3 ribs, and her doctor, and she had a whole bunch of injuries, and her doctor had said to her, we'll see you, you'll be lucky to get back to the gym in a year. And even then you probably will never really be the same. And she did it all, right? She did the red light, she did the thing, she did some peptides, but she powered down on the Stem Regen. And I think 3 months later, she went into her doctor's office, and he probably wrote her off as an outlier, right?
It was a wrong diagnosis.
Yeah. Oh, we probably messed up on the x-rays or something. And not to diss doctors. It's just that I think that you have 2 camps out there. You have the camp that in a situation like this will be like, what did you do? Like, how did you do that? And the other camp is kind of like, yeah, I don't have time for this. I'll see you later. Bye. Like, doesn't fit the narrative that I know.
Correct.
And we're just going to push you over there kind of thing. But using things like essential amino acids, using things that help manage inflammation, like you have that first inflammatory response that you want, but then calming, to your point, the chronic systemic noise, so that the thing that really stands out is the thing that needs the repair, is going to be really critical. So, okay, so you started off with this blue-green algae, which was super cool, but you didn't stop there, because there's a lot more to your formula than one thing. And I think that, well, I know that one of the things that really struck me when I read your book, and guys, if you don't know about this yet, Christian wrote a great book called The Stem Cell Revolution.
Cracking the Stem Cell Code.
Cracking the Stem Cell Code. That's it. Cracking the Stem Cell Code. And it's very easy to read. It's full of amazing information, but what you really get out of the book also is how precise you were. Like, you used specific plants from specific places, harvested under specific conditions. You're very deliberate about how you put this formula together. So I'd love you to talk a little bit about these plants, because it's an interesting concept that plants would be the agent that gets our body to do this thing. Like, you would almost think, oh, just eat bone marrow, right? And
yeah.
I mean, eating bone marrow is great, but that's not what's in your formula.
No, it's not. I mean, honestly, the real answer is I just followed scientific investigation. I make an observation, you test it, and if it works, then you continue. There was no preconceived idea, no ideology behind it, just following the data. So we discovered that blue-green algae from Klamath Lake puts more stem cells in circulation. The first response from the community in general, scientists would say either, 25%, because at the time it was an increase of 25% in the number of stem cells. It was the first ingredient, but not the most potent ingredient. It's just the first that we observed. So we developed a lot of the science around that ingredient. But at the time, scientists would say, 25% increase is not enough. And I had cases of paralyzed people getting mobility. So I'm saying, who are we to say it's not enough? It was enough for that person.
Oh, and 25% is a lot.
That's the other thing that I'm telling them. Do you want a 25% increase in your salary, or is not enough?
Yeah.
But so to get an answer like, it's not enough, it will matter when it's 100% increase. I just could not wrap my mind around it, but I would hear that from scientists. Other scientists would say, more stem cells, it doesn't mean anything. And hey, maybe it's bad for you. Maybe it's cancer. So that's the other one. And then from the attorneys, they would say, you're talking about stem cells. This is medical. The FDA will shut you down. And I'm saying, no, it's the body's repair system. It's a pure function of the body. We did not know it before, but it is a function of the body. So the first 5 years after we identified AFA was really documenting the mechanism of action. Because if you have an active compound and a mechanism of action, then your story is much more real scientifically. Then after that, the proof of concept. Let's trigger an injury in an animal and let's release the animal's own stem cells and compare with a placebo group. So then we did those kinds of studies. Then we filed the patent. So that was the first 5 years. But once all of this was done, it's kind of an obvious thing that if really we agree, we accept the body as a repair system, we evolved in symbiosis with the environment. Do you have only one plant that has an effect on the immune system? Is there only one antioxidant in the world? No, we're surrounded by all kinds of plants doing different things. So it could not be that there's only one plant. So I turned around and I asked the same question. We discovered AFA because it was bringing benefits touching various aspects of human health. So what else has been known to bring various aspects, of various types of benefits? So I first looked at so-called adaptogens. They do a lot of things in the body, but we don't know by what mechanism of action. So medicinal mushroom, goji berry, those kinds of things, fo tea from traditional Chinese medicine, they all have an effect on stem cells. But it was not the strongest. Where really we got the most interesting ingredients is when I had a chance to work with people who were investigating plants in remote areas of the world, like a scientist who had traveled to Papua New Guinea, the Congos, South America, and Madagascar to look for plants for Alzheimer's and Parkinson. So I asked her, do you have a plant where the healers are telling you, use this plant, it's good for everything?
Yeah.
So she laughed and she said, son, no, she didn't really say that, but it meant a little bit that plants, there's no plants that work for everything. So I went into the whole explanation of, no, I'm looking for one thing, stem cell release. But people will experience it in all kinds of ways, depending on their problems. So she was very intrigued by the concept. And I sent her a copy of my book. She read the book. And then now she understood really what I was meaning. So she said, in Madagascar, on their last trip, their guide and translator on the way to the airport stopped in a small market and scooped a whole bag of black beads. Like they look like black peas. And then said, test that. That's what you need to study. What do you do as a scientist if I tell you test that? You test it for what? Yeah. So she probably smiled, took the bag, put that in her suitcase, and that's it. It was in her freezer for 5 years, forgotten. So she sent me some of these beads. So we were obviously the guinea pigs in the early days. So we took a blood sample from ourselves, took the beads and another blood sample an hour, 2 hours later, and we saw so far it is the most effective product. So it happens to be little beadlets that are made, it's dried aloe, but one specific kind of aloe from Madagascar. They have 65 species of aloe in Madagascar, including aloe ferox, aloe barbadensis, aloe vera, the common types of aloe that are known to be edible, but that one is aloe macroclada. It's the only one that is used to make that specific remedy in Madagascar called vahona. So we then develop a system of harvest. It's a protected species. Mm-hmm. So you cannot just go and harvest it. So we did a survey of all the plants in the wild around Antananarivo with the University of Antananarivo. And then we developed a plan of propagation. So we've planted about 100,000 plants so far. So there's a community of Malagasy people that harvest the plant. So now we have a system of collection, processing. So now we're doing this product because it's a top ingredient. So as a scientist, what do you do? If it's not available, well, you make it happen. So that's what we did. John is in charge. A colleague of mine is in charge of all of this. He's the hero in Madagascar, but he made it happen. And now we have that supply of aloe macroclada, which is in Stem Regen. Then I came across, I'm in China. This is maybe 5, 6, 7 years ago. I'm in China and I have access to 3 biochemists, PhD biochemists that have studied plants from the traditional Chinese pharmacopoeia. So I asked them half jokingly, you're lost on an island and you can only bring one plant. What would it be of the entire Chinese pharmacopoeia? Yeah. And all 3 said sea buckthorn berry. I was not expecting that. I thought it was like it's a berry. I did not expect that. So I dove into scientific literature and I found that for 2,000 years in Tibetan medicine, Mongolian medicine, Chinese medicine, it's been used for disease of the lung cancer, heart disease, cardiovascular disease, diabetes, to help the body repair from bone fracture and burn to the skin. So look at the spread of benefits. Mm-hmm. So I'm thinking it looks like there's an effect on stem cells. So we derive our own extract, and something that has emerged from the scientific literature as well is that sea buckthorn berry growing at high altitude, where it's coming from originally, it has a very different biochemistry than when it grows at sea level, where Alexander the Great took it 25 2,500 years ago and brought it from that region to Greece. So we went on the Tibetan plateau working with a farmer, and we derived our own extract and we tested it, and we found that extract indeed puts more stem cells in circulation. So all these ingredients have this kind of story where we hone on an ingredient because of a hunch, but also kind of a lot of data from the scientific literature kind of suggesting that one mechanism of action could be stem cells. There are others, like, for example, gotu kola, Centella asiatica, known also for a lot of benefits. So we tested that as well. Very, very small release of stem cells, not really relevant. Foti from traditional Chinese medicine. So we tested a bunch of them. So what we have in Stemregen are the top 5.
Yeah. Yeah, no, that's great. Well, and as you said, what you're looking for is you're going into the lore of a society and looking for what's that thing that everybody takes, right? And so you're looking for that ingredient that produces pluripotent, like pleiotropic effects. That's the word I'm looking for. Another P word. That it just seems to, and so the stem cell would be the one thing that can affect all of these different systems. So I love that. I love that about this product. What I love about the product, and it's funny because a lot of people that I will talk to about it, they'll look at the bottle and they'll read it and they'll go, yeah, I don't know, like there's aloe and they kind of dismiss it. I'm like, no, you need to understand what's going on here. And so basically now in your studies that you've done on people's, when you measure, and this is a very important point, that you're able to measure the release of stem cells into people's circulation when they take a dose of this product. And I believe the number that you told me last time, and maybe it's changed because there's new research, was 10 million stem cells with every dose.
It's more than 10 million, but what I can say conservatively, because since the early days, for example, we have 3, I was thinking about this today, somebody asked the question, a colleague of mine, and we have 3 external groups that have duplicated our original data on the blue-green algae, and it's all published independently. I discovered that in the scientific literature. I was unaware of their work, and their data shows a stronger release than what we have published. The stronger release was 50% increase in the number of stem cells in circulation. And that is exactly what we had also in the early data. But the ones who had a very strong release, I removed them from the statistical analysis in case I was challenged. I wanted the data to be absolutely like nobody could attack it. It was very conservative. But what these other groups have confirmed is actually the original data that we have. So you just analyze the data that you get. You don't remove anything that looks like a possible outlier. And we had the same kind of thing. So that has been corroborated by other teams. And what was your question just before? I went into a tangent and I forgot.
I don't know. I'm so engaged in the answer of whatever question it is. I'm sure one of the listeners will be tapping away right now.
So you're saying, you're saying we were counting. Yes, we're counting stem cells. It is 10 million. But when I say 10 million,
it's base.
It's base. Like it's. I will say it's an average of 10 million, but it does not include all the synergy of the product. In reality, I would not be surprised if the number is more like 20, 25 million, but I cannot support it unquestionably from the data that we have. So I'm basically saying 10 million because that is solid.
Yeah. Okay, so let's talk a bit about some of the questions that people have when they hear this. So they're like, okay, so I'm going to take 2 capsules a day every day for, let's say, a month. And that means every day I'm going to release 10 million stem cells. And are they the same 10 million stem cells every day? Or do I have 300 million stem cells to release? And then am I not going to run out of stem cells after a period of time? Like, we've heard the term stem cell exhaustion in certain cases, and maybe you want to speak to what that really is and why, in this case, you're not likely to come across that problem.
Okay. Again, a lot of layers here. Let's try to
Oh, I
separate
tried to
them.
make it simpler. Okay.
No. It was simple, but there were a few questions. So the
Okay.
first one: do we release the same stem cells? It's like when you have a cold. Are you worrying that you might release the same immune cells? You just want your cold to go away.
Yeah.
I think that the discovery on stem cells make it look like something that is hard to accept. So we need to look at it from all of its angles, and it's good. It's good. But think of the answer just like the immune system. You release stem cells, what they will do once they are in the blood, a number of them will migrate out of the blood into a tissue that is in need of repair. These tissues are calling for repair. In the background, another number of them will migrate in various tissues that don't need repair. They just need maintenance. So there's a low grade migration. That's your constant maintenance system. As they circulate back in the bone marrow, a number of them will be recaptured by the bone marrow. And they will circulate like this in your body for up to about 6 hours, going either in the bone marrow or in a tissue. And 6 hours later, you're back to baseline level if you trigger a wave of stem cells. So are you going to release the same stem cells the day after? Maybe. Who cares?
Some.
It's still in the bloodstream to participate in tissue repair. Yes, you could be releasing some of the same. The point is that every time that you take 2 capsules of Stemregen, 10 million stem cells are scouting the body, looking for things that needs to be repaired. And that's what you want to do. You want to do this frequently. Exhaustion is a word that is very confusing because it's been applied almost invariably to 2 different phenomenon, and they're very 2 distinct phenomenon. Let's say, and we already talked about this, exhaustion in the bone marrow, let's not call it exhaustion, it's conversion. You don't exhaust your bone marrow. It converts from red marrow to yellow marrow, and it converts during all your life. You never die because you run out of stem cells, but you could die because you have less and less and less, and therefore less and less capability of maintaining the renewal of your tissues. And there's a point where your organs as a whole start to not be effective enough, and you slowly don't have the vital force that you need. So you will die of something, but you will still have stem cells in your bone marrow. I think the work was done some years ago with somebody that died, I think at 104, 106. And then they looked at what was in the bone marrow. There was still stem cells in the bone marrow. I think if I remember well, they reported there was 1 or 2 strains of stem cells, meaning like a population of stem cells remaining in the bone marrow. So it's exhausting. It's getting to the end, but there's still stem cells in the bone marrow. That's conversion. Red marrow converting into yellow marrow. Stem cells leave the bone marrow, they go into your blood, and then they migrate into a tissue. Each tissue has in around the area of the entrance of the artery feeding that organ, there is an area that is normally where you find the stem cell layer. They penetrate that area and they stay there. And in that area, they form the stem cell layer of that tissue. Some of them have been known for a long time. In the muscle, they were called satellite cells. Yeah. In the liver, they were called oval cells. And now with the new stem cell knowledge, we understand they were simply stem cells of that tissue. Now we know every tissue have its own stem cells. So stem cells migrate in that tissue, form that layer of stem cells. Those stem cells are utilized for the maintenance and repair of that organ. Now, see what happens in a tissue if you get constant stress and insult or injury to that tissue who constantly tries to repair while you have a declining number of stem cells in the blood flow to replenish that population. That layer will get exhausted. That is stem cell exhaustion in a tissue. That tissue that no longer have stem cells is deprived of its ability to repair. And when you think that every organ and tissue in the body is constantly in this process of turnover, lacking this rejuvenation with new stem cells means that organ is doomed. Yeah. There will be a problem in the not too distant future linked to that tissue. So you want to be able to boost that ability to repair by putting more stem cells in circulation, and now you can replenish those tissues. There is one set of circumstances where this is relatively well documented, but easy to understand. Take colitis, ulcerative colitis, Crohn's disease, any of those problems of the gut where the day that you have blood pain, like you're in an acute phase of the problem, that means that area is exhausted of stem cells, cannot repair. If you release stem cells or you inject stem cells, these conditions respond very well to stem cell treatment because you replenish the stem cell layer and now you can repair you can patch the part of that of the gut that was leaky, that could not repair. You did not resolve the issue. The person still has the same problem because we did not address the cause, but you have replenished that exhaustion, if you want, that made that problem to be acute. So that is stem cell exhaustion. It is the cause of aging. Behind this, the underlying cause of all stem cell exhaustion is the decline in the number of stem cells in circulation caused by the shrinking of the red marrow into yellow marrow.
Yeah. And I
hope that makes sense.
Yeah, no, that totally does. And what's interesting, you mentioned satellite cells in the muscle, and we know that the satellite cells in the muscle decline as we age, which leads to muscle loss and aging. And
correct.
So, so there's definitely an argument that says here, if there was a way, like, theoretically, to help to replenish those satellite cells with the infusion of more stem cells, you might be able to offset some of that difficulty of building new muscle as you get into your 60s and 70s and so on. So
So you couple releasing your own stem cells, whatever means, fasting, exercise, or Stem Regen. You put more stem cells in circulation and do activities that is intense enough to trigger some micro lesions. You trigger the migration of stem cells into the muscle. So you replenish this population of satellite cells. And then in the muscle, not in a lot of organs and tissues, but in muscles, these satellite cells will merge with existing muscle fiber. And that is why as you age, you get more and more nuclei in a muscle fiber. It's because you get a lot of that merging. So you build the body of the muscle, like the bulkiness of the muscle, which is strength. So you also get benefits in actual strength as you maintain, as you exercise.
And I love what you just said. Like, there's no real shortcut. Like, at the end of the day, you still have to provide the stimulus. You have to give the body the signal, we need muscle, because otherwise the body's like, you know what, I'm busy. I got other stuff to do. The heart theoretically is more important than my biceps or triceps. So I'm going to focus my attention there, kind of thing. So, but by working the muscle, you're bringing attention and that stimulus. Okay, so
actually, what you just mentioned there, Nat, is really to me the heart of biohacking with stem cells, because studies have shown that if you inject, so the compounds that an injured tissue releases to attract stem cells is called stromal-derived factor 1, SDF1. So far, the only compounds well documented to attract stem cells. So if you inject stem cells in the blood or make an animal release its own stem cells, and then you inject in the heart SDF1, you would expect that now stem cells will be attracted to SDF1 and will migrate in the heart. So that way we could direct where stem cells are going, but it does not happen if the heart does not have an injury. So there's something else that belongs to an injury that has not yet been identified that is part of this entire equation. So part of biohacking is to say, what can we do to really make an organ signal so that it can really call for that repair? And then we go back to red lights, pulse electromagnetic frequencies, different things. And I've said for years, and I have tons of empirical evidence of that. No study so far, but tons of empirical evidence. If you use the part of your body where you need the repair, you will enhance the repair. So people coming and say, oh, I have problem with my knee. Take Stem Regen and squat. Go take a walk. Yeah, but I have pain. Exactly. That's what I want you to have. Not extreme. Don't do it to a point where it makes your life miserable, but just enough to signal. To me, the stellar case that I often use as a point of reference is years ago, somebody came with a stroke. He was having aphasia and paralysis of his arm, and he was a singer. So he could not sing anymore, and he was very depressed. So he started taking the product, and I told him, why don't you try singing or to draw with your hand? And he was with his daughter, and I could see that he was getting agitated. And his daughter says, well, he's angry because you're asking him to do the things that he cannot do. And I said, I don't care whether he does it or not. I don't want him to sing. I want him to try singing. So now the body expresses its deficiency. It will signal from that area. He tries to draw. He's not going to be able to draw, but he's trying. So now it signals to the brain where the brain is faulty. And within a matter of 4 to 6 months, he was back at the choir. He was not speaking well, but he was singing well. So he was out of his depression and he was happy, and he had regained some mobility. I don't think he was ever a great painter, but he had regained some mobility. So the conclusion to all of this is that make the area where you want the repair, use it, make it active, make it signal in the body, make so that area tells to the stem cells, that's where I need you to go.
Mm-hmm. Yeah, no, that's, and I think that I remember interviewing a doctor a couple of years ago about injuries in general. Like, she's an orthopedic doctor. And one of the things she said is, people get injured and the worst advice that they get from their doctors is, oh, you need to rest, go sit down. And not that they don't necessarily need to rest, but you need to move. And whether, even if, depending on the injury, even if it's pointing and flexing your foot, or, in the case of a knee, bending and straightening a knee, if you can't do a squat yet, but bringing blood flow to the area, which by the way, most likely, based on our conversation, is also going to bring stem cells to the area along with everything else, is going to be ultimately the path towards leading to any kind of healing and regeneration in that area. So, I think that when we get hurt, sometimes the tendency is just to say, okay, I'm just not going to, I'm not going to do anything, and not realizing that in a way that's kind of sealing your fate. So, okay, we've been at this for a while. I want to get into some of the case studies. I want to talk a little bit about the cardiac study that you were just talking about. I think it's important to understand that a lot of these are not so much the cardiac study, but you have some very powerful stories that some of them are documented in Cracking the Stem Cell Code. There may be some new ones since then. I'm sure there are, actually. I'm quite positive that there are, but of really eye-opening cases of people that, in addition to whatever else they were doing, also added this product into their therapy and achieved really incredible results.
Yeah. And like we talked a lot in various parts here of this discussion, we just need to think that stem cells are the repair system. Anything that is broken requires stem cells to do repair. And we just happen to not have enough stem cells in our older age to be able to repair effectively. Here's kind of a little bit of a silly analogy. We know that water is essential for a plant to grow. Let's say as we age, we have less and less water. In your 50s, you only have a few drops to put on the plant. And I'm giving you a whole glass of water to pour on the plant. And now the plant starts to grow. We're not doing anything miraculous here. It's just that we've never given that plant enough water to grow. When you do, it grows. Your body is the same. The reason why these problems develops and don't seem to get better, and then it's hard to get out of them, it's because you don't have enough of the building blocks for repair in your body. The moment you give those building blocks to your body will utilize them. And that's all that we do. So the product itself, whichever product that I have studied over the years, they don't do miracles. All they do, they make your body release more stem cells to deal with problems that between you and I, you never had when you are 10, 15, 20, 25. They did not exist. Part of this is because you had enough stem cells to offset those problems, so they did not exist. So it's really important to understand. You put more stem cells in circulation, you just give back to your body its innate ability to repair. And we've had a number of cases, like you talked about, that we have published using different combination of these ingredients over the years. Some of this, you may or may not be surprised by what I'm going to say. We've had, of course, hundreds, if not thousands of these cases. The sad reality of those is that most doctors do not collect data for the purpose of publishing through peer-reviewed literature. They collect data to make their patient happy and have the treatment be successful. And who am I to criticize that? That's what is the aim of that relationship. So we've gone through so many of these cases. And at the end, when we really analyze all the data, very few cases we have the data to be able to publish it to peer-reviewed literature. So at the end of the day, although we do have hundreds and hundreds of cases, few of them have been published, but some of them have been published. Some of them touch the heart. So we have then started, because of all the cases that we've had on the heart, we started a study on stable congestive heart failure. The reason why, so the protocol of that study, we want to answer a few questions. Number one, what is the effect of Stem Regen, or this blend of plants that I put together, on heart function? How does it compare with stem cell injection, and how does it combine with stem cell injection? Because I'm doing this with a cardiologist who has used Stem Regen in his treatment, in his protocol for many years. And he says, Christian, I'm getting better benefit, better results than all my colleagues. And they're asking me what I'm doing. And I share with them that I'm just giving them your product. But they look at me, they slap on the shoulder, and they laugh, thinking that I have a secret that I don't want to reveal, because nobody can understand or wrap their mind around the fact that simple, stupid herbal extract can have such an impact in the body. So that's what that's what we wanted to do. So now we have gone through 10 people per group. So one group is Stem Regen, one group is stem cell injection, one group is combination of both. In that process, 10 out of 10, just with this blend of herbal extract, all these patients have normal heart function after 6 months. These are people that had at least 2 years of chronic stable congestive heart failure. We have similar data, similar results with stem cell injection, a little bit better. When you combine both, they get much better results, almost twice the benefits. Wow. So that study is giving us really what we thought, based on all the observation over the years, what we are going to get, which is that if you get stem cell injection and they're adipose or umbilical, they're younger. So you get, in a short amount of time, a better push. Mm-hmm. But if you release your own, over time, you pretty much get like the same kind of results. And over time, it does not just address that problem that you have on the day that you get that treatment, if you want, is just everyday life as you age. So it's more touching like longevity, quality of life, aside from the problem that you would like to resolve. And again, it's not the product. We release your own stem cells. It's just showing what your own stem cells can do.
Yeah. Well, and what I love about that too is, I mean, look, if people can afford stem cells, that's great. And they want to go that route, but it's the stem cell injection plus the Stem Regen blows everything else out of the water, right? And that speaks to what you said, where you get the injection on that day, and for however long those new stem cells last and are able to signal and do what they do, you get that healing impetus. But then by backing it up with providing stems, like that stimulus to release more stem cells for weeks and months forward, you end up with a much better result.
Correct.
Right. So because that stem cell injection is a moment in time.
Correct.
And now you're backing it up. And I think that one of the interesting applications for this product is even with doctors who do stem cell work, because it can kind of augment and amplify the results of what they're seeing with the injections. But for Joe Blow on the street, I think, it's a very intriguing opportunity to get access to a therapy that, as you've been saying over and over in this interview, it's in there, it's here, it lives in your body. All we need to do is kind of give it the impetus to kind of come out and do its thing when you need it. Now, one thing I wanted to talk about also is there is a dose dependent response, right? Like you're in the more severe cases that you've talked about. And I definitely, guys, I've said this before, I'm going to say it again, check out the book, because there's lots of really good stories in there. You're not just taking 2 capsules a day, like in much more advanced cases where you need a much bigger effect. People do take more of the product during the day. And I think that speaks to another point, which is there's more to be had. Right. So if you double the dose or triple the dose or quadruple the dose, you're going to get more stem cells that come out to play.
Correct. I think the way to think of it is you take two capsules, you release one wave of an average, let's say of 10 million stem cells. They are there for 46 hours in your bloodstream. So if you can send another wave later in the day and then a third one later in the day, so you give more opportunity for repair in the body. So in our study, we do two capsules 3 times a day. But I want to be clear because it's creating almost like a how like an expectation that may not necessarily be accurate. And what I mean is that the cases that we published before, those that are in Cracking the Stem Cell Code, for example, these were not, for the most part, one of those cases was a prospective studies in which we found patients and then we provided the product. And to those, we gave them enough product for them to take as much as they wanted. But all the other cases, so somebody on a heart transplant list, which 2-3 months later is off transplant list, is actually abnormal heart function. Someone with a stroke, someone with kidney failure, someone with Parkinson, all these people, all they did is that they read the label and they took what was on the label. Take 2 capsules a day.
Wow.
So in our study, we go higher for 2 reasons. I have seen now enough over the past 20 years. It's clear that it is dose dependent. It behaves like more waves in a day is better. So let's make sure that we do a study. We have participants, we have a clinic, we have doctors, we have it's expensive to do research. I'm just feeling like I would feel very stupid if 2 years down the road, I'm looking back and I'm thinking, maybe we should have given more.
Right.
So right now I'm in that phase of research where I just want to show, here's what your stem cells can do. And yes, I'm using a lot, 2 capsules 3 times a day, but I want to show, here's what your stem cells can do. Then we can do future research where we start to fine tune, what do you get at such and such dose? So I'm just saying, you don't have to go that high, but if you don't feel the full benefit, let me put it this way. I think that the best way to take it, if you have a problem that you would like to resolve, take 2 capsules 3 times a day for the first month. See what your body can do by a real boost in putting more stem cells in circulation. Then in your 3rd, 4th week, go back to 2 twice a day or 2 once a day, and then see, am I seeing the same benefit? Is that boost during 2-3 weeks was enough to catch up? And now you go more like on a maintenance level. If you realize, no, I'm not doing the same, go back. So your body is telling you, no, I'm doing better when I'm having more stem cells in circulation. And typically, you will have people going for 1, 2, 3 months. And after that, they realize that, 2 a day maintenance is good enough. So they needed a period of like more intense repair. So that would be probably the best way to start taking it.
Yeah, no, that's a great plan. Now, what about for people who just want to take it for, I mean, you mentioned earlier, like there's also just regular maintenance. Like you don't necessarily,
Correct.
And I mean, let's be clear, like, you know, you don't have to take this all the time because your body's going to release some stem cells and the whole 9 yards. But for those of us who are a little bit more focused and say, well, you know what, I want to make sure that I've got enough stem cells around on a daily basis to deal with the wear and tear of regular life and things that maybe, you know, I think one of the things we underestimate is sometimes we have trouble brewing. We don't know it until further down the road. Right. So what if, and we don't know for sure, but let's say what if by using something like this, we can offset those problems or avoid them from developing.
That's the topic of my 2nd book that I'm going in vacation to partly work on. So
I thought you weren't working on your vacation.
I know, but I don't know if I can. But in any case, it will be done this year. Okay. So, and it's really the fact that everything that we've talked about now for however long we've talked about is repair. And so almost all the research was all about studying the ability of stem cells to achieve repair in the body. But in the process of those studies, let me give you a typical example. You irradiate an animal, you inject fluorescent stem cells. So now the animal has fluorescent stem cells in its bone marrow. Now you trigger an injury and you observe what amount of repair comes from stem cells, and you can see it and visualize it easily because you see the area being filled with cells, new cells of that tissue, but they're green, meaning that they came from the stem cell. So that's the kind of study that has been utilized to really visualize and expose and document this process of repair. So at the end of that study, sometimes you're left with 2-3 mice that you don't need to sacrifice. They become pets in the lab. And 6 months later, the question comes up, let's go and look at the animal and see where else do we find cells that are green. And then this whole thing was revealed, is that while stem cells go primarily where there is an injury, they also go everywhere else to a smaller extent, but as a process of just normal tissue turnover, like renewal. Now, the question was, do we see this in human? And there's one set of circumstance where you can see this in human. It's women receiving for the treatment of leukemia, they receive a bone marrow transplant from a male compatible donor. So that means that now after the bone marrow transplant, the woman, her stem cells now all have the Y chromosome. So now it's all male cells are going to repair from that point on. So they went into bank of tissue biopsies taken at the autopsy when women who received bone marrow transplant passed a year, 5, 10, 15 years after the bone marrow transplant. And then the whole phenomenon was revealed. If you look at various tissues, but also various amount of time after bone marrow transplant, the whole picture now becomes clear. The entire body is constantly in a process of turnover. You have a new skin every month, a new liver every 2-3 years, half a new heart every 25 years. Everything is in turnover. Turnover means you lose cells every day, and to stay healthy, you need to replace these cells. It's like a bank account. If you have $100 in your bank account and you want to keep $100, if you have more and more expenses, then you need to have more and more income. Yep. But your income declines, your red marrow shrinks, you have fewer and fewer stem cells. And as you age, you lose more and more cells. So more expenses, less income. There's a point where you don't have enough stem cells to offset cellular loss. And that's when you start to develop what will become 10, 15 years down the road, a disease. So I published this whole understanding of the role of stem cells in disease formation in 2013. And I said, there's one way to test if that view, this theory, this understanding makes sense. Let's go count the number of stem cells in people who have developed various kinds of so-called age-related diseases. And let's see how it compares with healthy people of the same age. Now there's probably about 50 of those studies done. You count the number of stem cells in people with diabetes, atherosclerosis, heart disease, erectile dysfunction, liver failure, kidney failure, emphysema, Parkinson, Alzheimer's, lupus, arthritis. The list keeps growing.
All the things.
In all those studies across the board, the people who have developed those diseases have on average 50% or less than the number of stem cells that you find in a healthy person of the same age. And just think about everything that we've talked about today. It makes so much sense. If you have fewer stem cells, you cannot maintain like you used to your organs and tissues, and they slowly start to decline. And if you have genetics, lifestyle, diet, whatever it is that makes your heart more susceptible, then it's going to be heart disease. If it's your lung, your pancreas, whatever, that is the problem that you're going to experience. So there's 2 things that you can do to really prevent those problems from happening. Number 1, adjust your lifestyle so that you reduce the stress that is put on that weak part of your body. So you tone down the speed of cellular loss and put more stem cells in circulation to offset that cellular loss. And then you will allow your body to stay healthy like when you were 20. And then you won't develop the problem. You won't lose the health that you have today. So all of this to say, yes, there's a direct link between how many stem cells you have today and every day of your life for the next 20 years and the health that you will have in 20 years.
Yeah, no, I love that. And I think the other point is that even if you're older, you can get your body to release more stem cells. And that's the nut, right?
Yep.
That's that little nut. And we see those people with those very healthy lifestyle habits, maybe that are naturally stimulating their own stem cell release, like those people up in northern Pakistan you were talking about who are living in a constant state of caloric restriction and harsh conditions in the whole 9 yards. So we don't live like that. And so nevertheless, it behooves us to adopt as many of the healthy lifestyles as we can, but then we have access to a tool like this. So, okay, so we're going to wrap this up pretty quickly because even though I said we had lots of time, now we're going to run out of time. And we're going to release this podcast a couple of weeks before a big event that's coming down the pipes, where Stem Regen is going to play a prominent role, which I will let you break the news or not break the news, whatever you decide. But you've gone the next step now, right? You said, okay, we've got this formula that's very effective at stimulating the body's mobilization and release of its own stem cells. And, in true scientist form, you're like, okay, so what else can we do to help those stem cells get to where they need to go and end up where we want them to go? So you're launching 2 new products, or 1 new super
Correct.
product at this event. We can say, the event. Well, I'm going to let you spill the beans. I'm going to sit here and hold on to beans. And
there you go. So Stemregen is the title sponsor of the Biohacking conference in Dallas in May, at the end of May. So, and we're really preparing here for the first time, to have really a substantial presence where there's opportunity for everybody to come ask questions, and we will be launching, if everything lines up the way that it's planned, we will have 2 products, new products ready to launch at the Biohacking conference. And it's things that I've worked on for years. So there's nothing new in it. I have used products like this before. I have seen what they can do. The only difference here is that these are more at the cutting edge of the research, if you want. So they're much more effective than what I have played with before. And it's to understand that once you've released stem cells, there are two things that can reduce the ability of stem cells to achieve their role of repair in the tissue. Number 1 is microcirculation, meaning the size of a stem cell, which can go up to 20 microns, needs to go to a fine capillary that is about 12 micron. In order to achieve this feat of squeezing itself into the capillary to reach the tissue, there's a number of conditions that must be met. If these are not met, the stem cells sort of bounces and cannot get to that tissue. And I believe that is one of the hallmarks of chronic conditions. Those organs are deprived of the repair capacity of the body because stem cells don't have access. So you need to have good fluidity of the blood. So fibrin buildup in the blood, we remove this with nattokinase. We have nitric oxide precursors to dilate the capillaries. We have bioflavonoids and components that are going to support the health and integrity of capillaries. So they're strong, but they can also dilate effectively. And rebuilding polysaccharides to rebuild the glycocalyx, which is that layer that allows cells to kind of slick through capillaries. So it is one product that brings these 4 types of technologies into one product, all aimed at enhancing microvasculature. But now, as stem cells are circulating everything, there is one signal that is calling them from an injured tissue. That signal, we talked about it briefly before, SDF1, but SDF1 is part of a soup of compounds. They're all inflammatory compounds. When you have chronic conditions, that inflammation in one tissue starts to leak and build up in your overall blood vasculature. So it becomes systemic inflammation. So systemic inflammation acts a little bit, if I simplify it, as lowering your signal to noise ratio. There's too much noise in your blood, and the stem cells cannot differentiate between what's in the bloodstream versus what is coming from an organ that is in need of repair. So if we can suppress all that background noise, by suppressing systemic inflammation, then we can make stem cells more effective at identifying those tissues that are in need of repair. So these are the two new products. So you release stem cells and you basically take these 2 companion products that boost microcirculation, improve what we call the signaling of the tissue so that stem cells can better find where they go. And then you really have sort of the big trio, like the big combo here to really boost not only stem cell release, but stem cell function in the body.
Yeah, I love it. It's going to be even better.
I'll send you some when we have prototypes. I'll send you some.
No, it's going to be even more better. I mean, it is remarkable. I think that, what you've achieved with this formula has been remarkable to date. And to think that you're now going to add on another layer to increase efficacy, it'll be pretty exciting to see how that unfolds in your trials and in all the stories that you get. You better go to Hawaii and to your holiday and rest. Sorry, guys, but you don't know what island he's going to be on. So, and he'll be back by the time you're listening to this. But yeah, you better go rest up so that you can deal with the hordes when you get back. All right. Stem Cell Christian, your handle on Instagram, if anybody's looking for you.
That's right.
Tell
I thought
people.
Drapeau, most people could not spell it. So Stem Cell
Yeah, it would be
Christian.
confusing. I mean, I like Drapeau, but then I say it French and people look at me funny. So I think Stem Cell Christian says it all. So why don't we tell people where they can find you, how they can find out more about the product, where they can buy your book, because it's a great book. Of course, they can come visit you in person at the Biohacking Conference last week. Last Thursday, Friday, Saturday of May.
Correct. Stem Cell Christian on TikTok, on Instagram. The book, I think, is available from the TikTok shop. But other than that, on their website, stemregen.co, Stemregen is there. And the book is also available. I think the book is also available on Amazon. So that's it. And then we'll see a lot of people at the Biohacking Conference.
For sure. And you guys, if you're shopping online, you can use code NAT1515, and that'll get you 15% off your full first order, which is a beautiful way to start your relationship with Stem Regen, I think. So thank you so much for your time again, Christian. I look forward to seeing what comes next for you guys. It's going to be exciting. And very much looking forward to seeing you and Stephanie at our next event.
Same here. Thank you so much.